All right, so here are the solutions for yesterday's homework. So moving on. So since we didn't have any homework questions, we're going to move into 21-2, which is formulas for geometric sequences. So today we're going to look at writing a recursive formula for a geometric sequence, write an explicit formula for a geometric sequence, and use a formula to find a given term of a geometric sequence. Are we ready? Page 316. All right, so the first part, remember that the numbers of a sequence are called terms and that you can use sequence notation, a sub n, or notation, function notation f of n to refer to the nth term. So use the above notation to rewrite the first 4 terms of the viral video sequence was referring to yesterday. Also write the common ratio. So f of 1. So how many did we have in the first term? If we had, what was the first stage? We had 1 person, right? It was Keisha. Then in the second one, how many people? Now just in the second stage, how many people received that viral email? And then the third stage? And then the fourth stage? All right, and then our R was going to multiply by 3. All right, so what, and then what it says, also write the common ratio. So each time what was happening? Okay, so multiplying by 3. So what is the value of the term following a sub 4 or f of 4? Write an expression to represent this term using a sub 4 and a common ratio. So what are we doing to get to a sub 4? What do we do? Okay, so we took our a sub 3 and we multiplied that by 3, right? And that gave us our a sub 4. This was our previous term times 3. So just as with an arithmetic sequence, you can use a recursive formula to represent a geometric sequence.
Could I please have Carter, Brody, Adrian, and Hallie come down to?
All right, so a recursive formula is a formula that gives any term as a function of the preceding terms. So here we have our table, and they've already kind of started filling it out. So in our first stage, we had 1 person, and that goes for our a sub n and our f of n, 1 person, and then the total number, or the number of people who have seen the video, we have 1 person. And then in our second stage, we had 3 times 1, or 3 times our previous value for both, and then that gave us 3 more people. And so then in the next one, we had 3 times our second stage, so we had 9 people added to it, right? So then why don't you take the time to fill in the next 2 stages, which is kind of what we did in number 1, and then we'll come up with a generic way of writing that. All right, so we filled in the pattern. We continued the pattern for the next 2 rows. So we multiplied each previous by 3, and we wrote it in both notations, and sequence represent notation and function notation. So now if we're building a generic formula, what would this line read?
3n.
3. Now this is n, so it was 3 times each previous, right? So what would be the one right before n? And so this one this was row 3, n minus 1. So we just take, like this was 3, so this was 3 minus 1. This one was stage 2, so this was 2 minus 1. Here's stage 4, and so this was a sub 3, so that would be 4 minus 1, and so on. So a n minus 1. And then for the function notation, it's still 3, but what goes in our f? F of what? This was 5, so we had f of 4. This was f of 4, and so we took 3 times f of 3. So this would be f of, what would be then? Like here we have f of 3 for stage 3, and then we take 3 times f of 2. So this is stage 2, and it's 3 times f of 1. So what are we doing from 2 to get to 1? So we're multiplying by that previous stage. So what's the stage right before f of n? N minus 1. So that would be the stage right before. Alright, so the recursive formulas for the viral video sequence are partially given below. Complete the formulas by writing the expression for a sub n and f of n. So here we have a of 1 equals 1, or a sub 1 equals 1. A sub n, what would that be? Well, if this is stage 5, are there 5 watchers? No, so what would we have? So 3 times. So depending on whatever stage we're looking for, we're going to take 3 times whatever that previous stage. So if we're looking for stage 5, then we know that if we're looking for stage 5, we want 3 times whatever stage n is, right? Does that make sense? Alright, so now in function notation, how would we write that? Yep. 3 times whatever the previous stage was. Yeah, there's someone right there. Alright, questions? Alright, so let's kind of pause here and do the check for understanding. Let me put this up. We'll do this one together. So here, Jordan says we're dividing by 4. Does that make sense? So 64 divided by 4 is 16 divided by 4 is, and 4 divided by 4, 1. Now with the recursive formula, we typically don't use division, but division is the opposite of multiplication, right? Opposite functions. So when we're dealing with an arithmetic sequence, we really don't use subtraction, but instead we add a negative number. So when we're dividing, we're really multiplying by what number? Well, here, if we're dividing by 4, that's the same as multiplying by what number? 1/4. So here we have 1/4. And then how would we write that as a recursive formula with our a? And then what would go here? The little subscript. We're taking 1/4 of the previous term, right? So how do I write previous? How do I indicate n minus 1? So we're taking 1/4 times whatever the previous value was. Think you're ready for to try the next one? All right. So I'm going to pause YouTube. So it's the same pattern with a sign change. So this one's going to be that negative 1/4 times our previous value. I just read the directions real quick, and it also says include the function notation. So how would we write these each in function notation form? So is this number going to change? Is that 1/4 going to change? No. So now instead of doing
It'd be 1/4 f
yeah. So now we're just taking this n minus 1 and putting it in our function. So now it's just saying take the previous number and multiply by 1/4. What about number 5? How would we write that in function notation form? Perfect. All right, now this last one, number 6. This one's tricky. We have -1, +1, -1, +1. So we're taking for each stage, previous stage, and we're multiplying by, like Kelly said, -1. So then how do I write n minus 1 and then in function notation? Perfect. So that's just saying you take whatever your previous term was and multiply it by a negative, and that's just, you're not changing the value, you're changing the sign of it. All right. So questions there? All right. So now it says use the recursive formula to find a sub 6, a sub 7, a sub 8. So in order to find a sub 6, we need to know a sub 5, right? I think you guys found that in your table. So we had a sub 5 here.
Oh, that's
81. So to get a sub 6, we're going to take to get a sub 6, we're going to take stage 5 and multiply by 3. So stage 5 was 81. So what's 3 times 81? 232. All right, so take a second and let's get a sub 7 and a sub 8. All right, so questions on how we got stage 7. Right, 242 times 3 is 729. Then for stage 8, you take 729 times 3.
How can you get 726?
Oh wait, hold on. What's wrong with my number?
It's supposed to be 3.
It's supposed to be a 3. So if we, I don't know what I did. All right, so 243 times 3 gives you 229. Times 3 gives you. Okay, yeah. If we use the correct numbers. So Nate was correct with using my number, but since Mrs. Cheshire was wrong. So this number is 2187. I was close. I was like the point to show you work, right? All right, so good there. Questions after we caught my mistake? So why might it be difficult to find the 100th term of the viral video sequence using the recursive formula? Yeah, and so you have to go through, you'd have to know what the 99th term was, right, to get the 100th, and in order to get the 99th, you'd have to know the 98th. So that's not real practical, right, to go through and do that math. So, as with arithmetic sequences, geometric sequences can be represented with explicit formulas. The terms of a geometric sequence can be written as the product of the first term and a power of the common ratio. For the viral video sequence, identify A1 and R, then fill in the missing exponents and blanks. So our first term was, for stage 1, how many people? One person, right? This is a video or an email? I forgot. A video, okay. And our R value was 3, right? Alright, so writing for stage 2, we have our first term times 3 to the what power gives us 3? 1, right? Because 1 times 3 is 3. And then 1 times 3 to what power is 9? Right, because you're taking your stage number, and then your power is n minus 1. So then 1 times 3 cubed, if we're following the pattern, is how much? 27. And then our next stage 5 would be 1 times 3 to the 4, which is 81. And stage 6 would be 1 times 3 to the 5th, which is 243. I heard correctly this time. My lack of listening skills. A sub 10, so our 10th stage is 1 times 3 to the 6th power, which is, oh, this is Cheshire not paying attention. So stage 10, so we need 10 minus 1, which is 9. I was just making sure you guys were paying attention. 19,683. Oh my.
That's 100.
That's a lot of people watching the video. Alright, so express regularity and repeated reasoning. Describe any patterns that you observe in your responses from item 9. Then use A1, R, and N to write a formula for the nth term of any geometric sequence. Alright, so Jordan had said that our power was our stage minus 1, right? So if we are doing a general formula for any stage n, what is our first term? That's our stage 1, right? So it's, in this case, it's number 1, which happens to be our starting value, right? So one person started with the video. So that's our stage 1 value. All right, and then what's 3? What value is that? What term? That's our R. And that's being raised to what power? N minus 1. So we're taking however many we start with, and then however many, like what are our value, how fast, like how many people it's spreading to, and then n minus 1 is our previous stage. right, so now it says, write the explicit formula for the viral video sequence. Use the formula to determine the 12th term of the sequence. What does the 12th term represent? So if we're looking for the 12th term of this sequence, instead of finding the 11th and then the 12th, how can we use this just to find the 12th? So what was our starting point? What was our n sub 1? How many people started with the video? One. There was one person in stage 1. So this is our stage 1 value, a sub 1. And then what's our r value? 3. That's how much it's multiplying each time. And then n sub 1. So what's the previous stage number? 11. So now we're going to take 1 times 3 to the 11th. $177,147. So at the 12th stage, this is how many people we're adding to our views. Yes,
So
ma'am.
like if the first term, instead of being 1, if it was like 5, and then it would like multiply each time, instead of having that 1 in parentheses, it's multiplied by 5.
Yep.
So, because essentially what you'd be doing is we have, our starting point of Keisha, and then she sent it to her 3 friends, and they each sent it. Well, you'd have that pyramid, but you'd have it 5 more times. So each stage would be 5 more times for that 5 starting point.
Okay, so it's like if the input's 1 and the output's like 5, then you just multiply it by 5.
Yep, this is just however many you had. This a sub 1 is however many you had at stage 1. What you started. So this is talking about a viral video. Where else would this geometric sequence, what other situations does it apply to? Besides the internet and what other things go viral? Gossip. People. Why wouldn't you say? Disease. So when you have one person who gets, and the last kind of thing, well, during flu season, you track if one person gets the flu, the germs, they spread it, and typically more than one person gets it. That's why, they really push for the vaccinations and, washing your hands and stuff. But, Ebola, in Western Africa, last year, 2 years ago, that was big. It spread quickly, Ebola. And that was, it was like really important to have clean water and stuff and educating those communities. And so viruses, so the World Health Organization, uses this type of math to kind of project, how things are going to spread so that they can better contain them and treat them. They can predict how much medicines they need and medical personnel to help treat and combat the epidemic. All right, so let's see. All right, so we'll do number. Let me see what's going through this quicker than what I thought, which is good. Do you guys have any questions? So we'll do number 12. So the explicit formula for a geometric sequence can be thought of as a function. What is the input? What is the output? So what's going into the function? What do you mean? Okay, so which term? Like if we look at our explicit formula, we have a sum. Right, yes, exactly. We need to know what that first term is. And so as that changes, the other thing, we have that R value. So different geometric sequences are going to have different R values. And then we also need to know the stage number. And so when we do that, what are we getting out of? Right, you're getting the number at that particular stage, right? All right, so when we do this explicit formula, in order to set up the formula, you need to know the number of your number at stage 1, right? And you need to know what your R value is. So what's the number that's going to change? The stage number, right? And so we can really see that if it's in function notation. Where your n is your input in that function notation. So while setting up our explicit formula, there's lots of input things, but the one thing that will change will be depending on what stage number we're looking for. So now let's look at the domain. What's domain? What does domain mean? It's your input, right? So in this case, our input is our n, and what does n represent in a geometric sequence? It's, well, like, what is it? It's our stage. And so, looking at our stage, we have a starting point, correct? Can we go past, like, beyond, like, back into the future of our starting point, or do we have a specific starting point? We have a starting point. That was where it started. And so we can't go, if we're looking at this viral video, we can't go back and look at before the video, right? Because it didn't exist then. So we can only go forward. So looking at our stage number, what's our starting stage number? 1. So if we're looking at our domain, we have to start at 1. Is there a stopping point?
Well, yeah.
At some point, the market will be saturated, and after everybody's seen it, right? But in theory, you can go on forever, right? As children are born, video is the first thing they see, right? We keep on growing. So, in theory, it's going to go to infinity. But what's another limitation of our domain? Can we have any real number, any positive real number greater than 1? Can we have stage 2.5? No. So our stages have to be what? All right, so all positive whole numbers greater than 1, right? So x is greater than or equal to 1. So we also need to state that x is our whole number. Alright, so we need to say that so that people know that we can't have stage 2.5. We can't have stage, square root of 3. That our stages are whole numbers. So we can say they're whole numbers, we can say they're natural numbers greater than 1. Alright, so then it says rewrite the explicit formula for the viral video sequence using function notation. And kind of back here. So if we're looking at the video, we have f of n. What's our a sub 1? 1. And then what's our r? R is 3. And then we have our power, which is n minus 1. Alright, So it says use a graphing calculator to graph your function. Is this function linear or nonlinear? Justify your response. So bring it up on Desmos. Looking at the equation, what do you think? Do you think it's going to be linear or nonlinear? I heard, what I hear? I heard nonlinear. Any other? So the benefit of function notation is we can, so 1 times 3 to the n minus 1. Oops. All right, so is that linear or nonlinear? Nonlinear, right? Pretty sure that's not a straight line. So this is definitely nonlinear. This is actually, anybody know what this kind of equation is called? It's a nonlinear equation, but do you know what type it is? Okay, this is an exponential. We'll look at that because it has an x. Your x is in our exponent, so that's changing that. The bell is going to ring. So your homework, I would like for you to do number 13, and let's just do number 13. So you're going to try it out, brand new one. Number 13, and then we'll look at that tomorrow.